This is page 881, and you have to have your page 880 handout. We highlighted on it. See, here it is. We got our highlights. We got our Julie and Erica and Miguel answers. So we're going to use those as we answer the questions on this page. Question 1, why is Miguel's response incorrect? Now, bringing back Miguel's response, I highlighted in our last video the 2/4. That was his answer for the probability of Walter to make the 2 free throws or make the 1 free throw. And he had this entire sample space like drawn out. That is correct to do. You should look at every possible situation of making and missing because the scenario is Walter is making 1 out of 2. Miguel's response is incorrect though because Walter's probability of making free throws isn't equal to missing. Right? There's that 1/3, 2/3 fraction or probability. Each time he shoots, he's got improving his free throws. He's working his way up to consistently making. Walter is shooting 2 free throws. Actually, where is the notes about the 1/3? Because that shows up here. Oh, he wants to make 2 out of 3, so which means he's going to miss 1 out of 3 times. So Walter's probability of making free throws will not equal probability of missing. Miguel doesn't consider that. Miguel says if they're the same, actually, Miguel would be right if the probability of missing and making was the same for Walter, but it's not. So Miguel's response is incorrect because Walter's probability of making free throws will not equal the probability of missing free throws. If they were equal, then he did it right. Okay, so part B, Julie. Julie has an incorrect response. She said 2/9 is the probability that Walter will make free throws, and 1 out of 2 of them. So she calculated the probability of a make and a miss. Julie's response is incorrect because she's not considering that there are 2 different ways Walter can miss 1 out of 2 free throws. I want to make sure I say that. Does not consider. Maybe you skip ahead to see how I finish writing this, all right? So I'm going to write it all out. You go scrub, scrub, scrub until you get to the part where I'm done writing the sentence. Because she does not consider that there are 2 ways Walter can make 1 of 2 free throws, being make miss and miss make. Okay, so I'm going to pause for a minute. Maybe you're back to where I am. You're trying to catch up on what I'm saying in this one. That Walter can make the first, miss the second, and that counts as 1 out of 2. Can miss the first, make the second, if I said that in the reverse. That's also the 1 out of 2. So make miss and miss make are 2 different ways. They have the same probability. It's definitely 2/9 and 2/9, but you got to consider them both. And so therefore, for that reason, Julie's wrong, but Erica's method is correct because she does consider both of the ways that Walter can make and miss, make 1 out of 2 free throws, and she does calculate the probability correctly. So I'm going to start writing, and you skip forward a little bit and then pause and see what I wrote. Okay. Erica's method is correct because she does consider 2 ways that Walter can make 1 of 2 free throws, and her probability calculation is correct. Okay, I kind of ran that one on. Julie's method is incorrect because Julie doesn't consider both of the ways. If Julie did, she'd be right. If Miguel had considered probability of what Walter's trying to achieve, which is 2/3 making, 1/3 missing, then Miguel would have had it right. So they both had this incomplete picture of what it took for Walter to make one out of the next two free throws, given that his form and everything that he was doing created him to have a skill of making 2 out of 3. So it's not equal. This is where it kind of gets a little bit weird and like numbers start floating around. Having a 2/3 probability of making means, all right, you got 2 free throws right now. You're going to make one and miss the other. What's that probability? So we're overlapping situations. And this is where our idea of trials and independence comes into play. How likely is it that if this is how he's typically responded, what he's going to do next, what we're expecting from Walter to do at the free throw line, based upon given like past performance. That's how a lot of decisions are actually made. What is your past performance? What's the probability that you're going to make a good choice? We don't really ask that question, but it's in the mind. We have a, somewhat of a mathematical reasoning brain. What's the probability you're going to make a good decision? How likely are you going to make a good decision in your next action or your next 2 actions? And good leaders can usually make good decisions all the time. Are you going to be a good leader? Calculate each probability. What is the probability of Walter making 2 out of 2 free throws? There's only one way that happens, and Walter is consistently making 2 out of 3 and 2 out of 3. So just by multiplying the 2/3 and 2/3 for 2/3 chance of making it, but it's going to happen in both shots. There's only one way. Miguel did it right. There's only one way he's going to make. None of these other of the 4 choices are a make scenario. So therefore, we don't need to worry about doubling up anything. There's only one shot at doing that. 2/3 times 2/3, 4/9. Okay, so to part B. How many different outcomes result in Walter making 0 free throws? And what is the probability of Walter making 0 out of 2 free throws? Well, honestly, it's about how he's going to miss and then miss again. And again, thank you to Miguel. Miguel did this right. You should be doing this too. You should draw out the sample space. He has the make, the miss. So 2 part B is considering the miss scenario. There's only one of them out of the 4 choices, so therefore we don't have to double up anything here. It's just the probability of missing times the probability of missing. Okay, did you notice that, first of all, just pause and ruminate on that for a second. We can still calculate probabilities of the situation given the past performance. So a miss is our given situation, and past performance is 1 out of 3 chance of missing. 1 out of 3 chance of missing. Multiply them to get 1/9. The final question that I have for you is, what happens if you take, let's get all these fractions in the screen, 4/9 from make, 4/9 from Erica saying make or make miss, and 1/9. What happens when you add up all 3 of those fractions? What is 4/9 plus 4/9 plus 1/9? It's 9/9. So if you have the probabilities of your situations adding up to 100%, one way that is useful is that guarantees that you've calculated all of the possible probabilities for the outcome. If you didn't have the probabilities add up to 100%, you're probably missing something if you needed to know that you had all probabilities, or you did a calculation wrong. We're not in this to be wrong, we're in this to be right, and we're in this to know more about probabilities. So, page 882 is next, talking about independent trials and multiple events or situations in those independent trials. So, thank you very much for watching this video, and I'll see you in the next episode.